Good morning, 6th grade. Lesson 44 in math today. We're back to the conversion thing. Hopefully it's almost memorized because you're about to get on a test pretty soon. 1 foot 12 inches, 1 yard 36 inches, 1 yard 3 feet, 1 mile 5,280 feet. Centimeter equals 10 millimeters. A meter equals 1,000 millimeters. A meter equals 100 centimeters. A kilometer is 1,000 meters. An inch is 2.54 centimeters. 16 ounces in a pound, 2,000 pounds in a ton, 1,000 milligrams in a gram, 1,000 grams in a kilogram, 1,000 kilograms in a ton. 2.2 pounds equals a kilogram. 16 ounces to 1 pint, 2 cups to 1 pint, 2 pints to 1 quart, 4 quarts to 1 gallon. 1 liter equals 1,000 milliliters. 1 milliliter of water has a volume of 1 cubic centimeter and a mass of 1 gram. 1 liter of water has a volume of 1,000 cubic centimeters and a mass of 1 kilogram. Water freezes at 32 degrees Fahrenheit and 0 degrees Celsius. It boils at 212 degrees Fahrenheit and 100 degrees Celsius, and normal body temperature is 98.6 degrees Fahrenheit and 37 degrees Celsius. Your mental math would run something like this. I multiplied, I got $3.20. Left one more time is 0.05. Said correctly, 5/100ths. Divide by 4 gives me 6. When I do the math for letter D, it says estimate first. So it's 600 divided by 10 and got 60. I took the square root of 144, which is 12. 12 divided by 12 is 1. F divided by 4 is 50 times 3 is 150. Find the range. Biggest number, 65. Smallest number, 15. Subtracted, 50. Start with the number of meters in a kilometer. That's 1,000. Divide by 10 is 100. Square root it. 10 times 5, 50 minus 1, 49. Square root it. 7 times 5, 35. Plus 1, 36. Square root it. 6. Problem solving, guys. Jess has 3 identical cubes. Each face of each cube is painted a different color: white, yellow, blue, green, red, and purple. If the cubes are painted in the same way, what color faces is parallel to the red, the yellow, and the green? Okay, so I attempted to draw those things for you guys. I don't know how good I did, but here's the pattern we have, and here's what I did, and I'll try to show it to you. Okay, so number one, I got out a number cube, and I stacked it like this. 1, 2, and on the right is 4. So I wrote down 1 is yellow, 2 is white, and 4 is blue. Then I switched over to this one, where I have 1 and 2 switching spots. So I have 1 and 2, guys, and to make them switch spots, I flipped it over. My 4 for blue is now on the left side over here, which tells me on the right side is the number 3, and that's red. So which face is parallel to blue? Red is. And that's the number 3. So I'm over here in my little pattern, and the number 3 equals red. So now I got to get red in the front. Great. And now I have to decide, what are these guys? Well, I already know what 1, 2, 3, and 4 is, so I need to get 3 in the front with a 5 and a 6, because I don't know what 5 and 6 are yet. But I know that 5 is straight below 2. So 2 was white, and it's on the bottom here. So I'm going to go to the one that I do know, which is the number 1. The number 1's on the left, so it goes with the number 6 over there. So yellow has to be purple, because I already knew what 1 was. So if 6 is purple, that means 5 has to be the white, which means green has to go with white. So they asked me those parallel ones. Now, guys, the easiest thing for me was to actually have a physical cube that I could look at, and what I did is I made numbers with it. Some of you might be in your head be able to spin that thing the way you can to get your answers. You need to know you, though, so that when they ask you this on a test, you can do those things properly on a test. All right, let's review yesterday's problems. When I'm switching from a percent to a decimal, left twice, 2 times. Percent means out of 100. Just take my percent and slide that thing left twice. When I'm taking a fraction and trying to make it a decimal, it's just a division problem. Top number in the box, bottom number outside the box. And when I'm switching a decimal to a fraction, my decimal is my numerator, the place value is my denominator, and then I need to reduce. A helpful hint, guys, when you're reducing decimals that you switch to fraction, if it ends in 1, 3, 7, or 9, it can't be reduced. If it ends in 0, 2, 4, 5, 6, 8, it can be reduced. So you might want to write yourself that little hint on, does it need to be reduced or not. Today we're going to go back to division answers, guys. We're just going to work a few problems with learning how to switch different answers in division problems and what makes sense and be able to do those things. Your yellow folder doesn't have any blanks to fill in. It's just some of the logic that goes with it. So here we go. It says you can write an answer to a division problem with a remainder in different ways. One, you could write with a remainder. We'll do that a few times now that we get this lesson, but guys, that's going away for us. You can write as a mixed number. You see that. We can also write as a decimal number. First, we add the decimal points to the dividend and to the quotient, making sure that we line them up. Then we add zeros to the right of the decimal point in the dividend, and we continue dividing. So you got 6.75. In some situations, we might round up. In other situations, we might run down. In this lesson, we will practice writing division answers in different ways. We will also find the best way to write a division to fit each situation. So what they're saying is, guys, we're trying to develop math logic in you. To say, I can read a problem and say, this, we should answer this as a decimal, we should answer this with a remainder, we should round up, we should round down, we should write it as a fraction. That's all got to come naturally to us. Example 1 says, divide 54 divided by 4 and write your answer first with a remainder, then as a mixed number, then as a decimal. Okay, so here we go, 6th grade. I have it on the board. I have 54 divided by 4. Set up, and away I go. So 4 goes into 5 once, 4, subtract 1, 14. 4 goes into 14 3 times. That's a 12. I subtract, I get a 2. Now I stop right there so I can start doing what they asked me to do. The first thing they said, write it with a remainder. So I'm over here on my answer key, and I'd write 13, remainder 2. The next thing they said is, they said, write as a mixed number. I have 13. 2 is my numerator, 4 is my denominator. I have 13 and 2/4 in my answer key, which reduces to 13 and 1/2. Now the reason I pause there, guys, is so I don't have to write the division all over again. The last way they said is write as a decimal, so now I just continue on. Decimal point 0, decimal point. Bring down to 0, get a 0 there. Just end it. Okay, 4 goes into 20 5 times. That's 20, problem solved, and I have my final answer of 13 and 5/10 written as a decimal. Okay, so please catch how I did that. You can write your division 3 times if you want. You could write 54 divided by 4 and then get your answer with a remainder, then start all over. I try to do it with just one division thing, but you got to pause in the middle to get your answers. Okay, underneath example 1, it says, sometimes a quotient written as a decimal number will be a repeating decimal. Other times it'll have more places than the problem requires. In this book, we show the complete division of the number unless the problem states that the answer is to be rounded. What that means, guys, is you always keep adding zeros until it comes out, unless you either, 1, know it's repeating. They're never going to give you one that's going to go 3.1786665 and you have to have like 22 decimal places. It's just not going to happen in this book, okay? 2 says, divide this by 9 and round your answer to the nearest thousandths. Awesome. Here I go. So 9 goes into 37 4 times. That's a 36. Subtract 1, decimal point is 4. Decimal point straight up. 9 goes into 14 once. That's a 5. Subtract. Bring down a 5, add a 0. Goes in there 5 times. That's a 45. Subtract is a 5. Bring down a 0. Goes in there 5 times. That's a 45. That's a 5. And I have my answer. It's going to be repeating 5, but they told me to round to the nearest thousandths. Tenths, hundredths, thousandths. Look to the 5, it goes up. So my answer is 4.156. So my book told me what to round it to, so it doesn't go on forever. After example 2, it says this. Problems involving division require us to interpret the results of the division and express our answer in other ways. Consider the following example. Vans will be used to transport 27 students on a field trip. Each van can carry 6 students. How many vans will be filled? So I took my 27 students, I divided them into 6 people vans. That goes in there 4 times, that's 24, subtract and get 3. How many vans will be filled? Answer A, 4 vans are full. B says, how many vans will be needed? Well, guys, it's not I need 3 more vans. It's I have 3 kids left over. I used 24 students so far. So I need 1 more van to carry these 3. So by answer A, how many vans are full? 4. B, how many vans are needed total? 5. I can't say 4 and 3, 6 and reduce it to 1/2. How many vans do we need? 4.5 vans. I know this van's only half full, guys, but you don't get half vans. Vans come whole. C says if all but 1 van will be full, then how many students will be in the van that's not full? The 3 students will be in the van that's not full. Okay, so guys, in the future they're going to say, you got 50 kids getting on a bus that can hold 30. How many buses do you need? They're not going to ask you the 3 questions. They're going to say, how many buses do you need? I need 2 buses. That could hold 60 kids. I only have 50, but so be it. That's an example of I have to take my answer and I automatically round up. Okay, now I don't round up because this is half or bigger. If I only had 25 students, guys, and I have a remainder of 1, I still need a bus for that one, or a van for that 1 kid, so I need it. I'll give you an example of rounding down. I decided to stop at McDonald's. I had $15 in my pocket, and I want to buy $4 Big Macs. How many Big Macs can I buy for $15? Well, I have $15. I want to buy $4 a piece Big Macs. I divide. 4 goes into 15 3 times, 12. Okay, I got 3 left over. Now the question is, how many Big Macs can I buy? I can buy 3. I can't buy 3 3/4. I don't round up. I can't afford 4. 4 costs me 16. So this is an example where I take my answer and I round it down because I don't have enough money to buy the 4th one. So I tried to give you an example where you round down. This was an example of where you round up. Your book will tell you if they want it as a remainder, as a fraction, or as a decimal. And that's what we're working on today, that common sense that comes with math. Okay, there's some example problems for you to do if this is a little tricky for you. If you're saying, I'm not really good with the math logic yet, work a few of those problems. It'll help you out with it. All right, I'll see you for the questions. 6th grade, here we go on lesson 44 with number 1. The rectangle is 24 inches long and 18 inches wide and was the ratio of length 24 to width 18. Divide by 6 over 6, guys, gives me 4 to 3. Remember, ratios we leave improper. Problem solved. Number 4, Rachel bought a sheet of 50 35-cent stamp at the post office. She paid the stamps with 20. How much did she get back? Step 1, how much did it cost? I bought 50 stamps at 39 cents a piece. Bring that 0 straight down. 5 times 9 is 45. Carry it. 15, 19. So I spent $19. Now, guys, it's cents here, so if you made it look like a $sign, 1212. She paid with a 20. It cost $19.50. She gets 50 cents back. Not an 8. She gets 50 cents back. Number 7. Copy the figure at the right. In paper, find the length of each unmarked side and find the perimeter of the polygon. All things are in dimensions. So, guys, we just got done with our L shapes, didn't we? And now we have a complex shape and a half. All right, let's start filling in what we know. We know 18. We know 16. We know 15. We know 4. We know 8. And we know 5. So I need to figure in 2 pieces, guys. And here's how I figure in these 2 pieces. Okay, I'm going to start here. I know this vertical is 18, and I know I used 8 of it. So if I draw a line like this, guys, this 8 minus from 18 gives me a 10. That 10 goes straight across here, which gives me a 10. Now I do 15 minus 10 to get 5, which tells you this little piece up here is 10 and 5 because it adds to 15, which means this piece over here is a 5. That is written really bad. That's a 5. Okay? That's a very challenging piece. So you have to take what they gave you on the one side to get the missing piece, take that across, subtract from, to get there. Okay, the horizontal is a little bit easier. I know the whole horizontal is 16. I know 1. I know 2. I'm missing 3. So I add my first one, 5, plus 4 is 9. Subtract from 16 gives me 7. Okay, I now have my 2 missing pieces. Now I have to add like crazy. And I'm just going to switch to squiggly so you can see them for a second, hopefully. Yep, good. See if it get away. Okay, so there's an 18. There's a 16. There's a 15. There's this 4. There's this 7. There's this 8. There's this 5. And there's this 5 that goes down there. All right, now I'm going to switch back to a normal pen and I'm going to start to add. 18 plus 16 is 34. 34 plus 15 is 34, 39, 49. 49 plus 4 is 53. 53 plus 5 is 58. 58 plus 7 is 65. 65 plus 8 is 73. And 73 plus 5 is 78. So I have 78 meters. That is a problem and a half, 6th grade. They're going to start to give these a few more times. Awesome. Number 8, write 75/100ths as a simplified fraction. So 75 over 100 divide by 25 over 25. Goes in there 3 times, goes in there 4 times. Write 5/8 as a decimal, top in, bottom out. Add a decimal, bring it up, goes in there 0. Goes in there 6 times, 48, subtract 2, bring the 0 down, 20 goes in there twice, 16, subtract 4, bring a 0 down 5, whoa, 5, 0.625 for B, memorize your eighths. Write 125% as a decimal, left twice, 1.25 for letter C. Number 9, what did I say, 9? Number 10, the expression equals which of the following? Well, I have 2 plus 3, 2 times 3 plus 4. So, guys, I could distribute it, which would be 2 times 3 plus 2 times 4. That looks a lot like the letter B. Number 11. The triangle numbers are numbers in this sequence. 1, 3, 6, 10. Find the next term. So I added 2. Then I added 3. Then I added 4. So I have 10 plus 5 is 15. Then I added 6, which would be 21. The rule of this function is a term we know in the position. So now, guys, instead of adding like I did, always adding one more, they give it to me in a formula. Look at B. Awesome. So it's n squared plus n divided by 2. The 5th term is 15 because 5 squared is 25, plus 5 is 30, divided by 2 is 15. Use this rule to find the 10th term. So 10 squared is 100, plus 10 is 110, divide by 2 is 55. You did that once for problem solving about 2 weeks ago when they were making stacks with a pyramid. Number 13, what composite number is equal to the product of the first 4 prime numbers? Well, the first prime number is 2, the next one is 3, the next one is 5, the next one is 7. I want to pair them together like this. 2 times 5 is 10, 3 times 7 is 21, and I wrote the number 20 instead of the number 10. And 10 times 21 is 210. Number 15. Each math book is 1.5 inches thick. A stack of 12 math books would be how many inches tall? Well, each one is 1.5, and I have 12 of them. So that's a multiplication problem. That's 3 over 2 times 12 over 1. Goes in there 6 times. 6 times 3 is 18 inches. And B, how many math books would be in a yard? Well, I know a yard is 36 inches, guys, so you could do 36 divided by 1.5 inches, or we'll just do that. 36 divided by 1.5 inches would be divided by 3 over 2. So I would stay, change, flip. 3 goes into 36 12 times. 12 times 2 is 24 bucks. Number 18. Draw a square 2.5 centimeters long. Sweet. What is the area? Well, guys, you should have this one memorized. That 25 times 25 is 625. 1, 2, 1, 2. It is 6.25 centimeters squared. What's the perimeter? Now I'm doing 25 times 4. That equals 100. 1 decimal place, 1 decimal place. The perimeter would be 10 centimeters, as I just get rid of that. Number 19, the coordinates of the vertices of a triangle are, what's the area of the triangle? Okay, we got coordinates number 1, -2 and 0. The next one is at 4 and 0. And the last one is at 3 and 1, 2, 3. And 3, 3. Okay, so I have a triangle that looks like this, guys. Now, for the first time, we don't have a right triangle. So the first thing I do is I figure out how far across it is. 1, 2, 3, 4, 5, 6. And then I just figure out how, here's my dotted line that I have to drop, guys. And it went up 1, 2, 3. So it's a 6 by 3. 18 divided by 2 is 9 square units. So, guys, it doesn't have to be a right triangle for us to figure it out. You just have to figure out this height right here. You did that by knowing it goes up 3. Number 21. You have P over 90 equals 4 over 18. If you're quick on the math, you know 18 times 5 gives me 90, so 5 times 4 is 20. Number 24, I am dividing 16 and 42 hundredths divided by 8 goes in there 2, that's 16. Subtract a 0, decimal point straight up, 4 down, goes in there 0 times. That's a 0, so I'm going to bring the next one down is 2. 8 goes into 42 5 times. That's 40 is a 2. Have to add a 0, bring it down. Goes in there 2 times. 16 is a 4. Add a 0, bring it down. Goes in there 5 times for 40. So my answer is 2 and 525 10,000ths. Had to add a couple zeros there. 25. 0.153 divided by 9. 9 goes in there 0, 9 goes in there 0, 9 goes into 15 once, that's 9 is a 6, bring down the 3, goes in there 7 times, and I have an answer of 17 thousandths. Number 26, I have 5 3/4 plus 5 6 plus 2 1/2, got to have common denominators which are 12s. Times 3's is 9 12ths. Don't forget your 5. Times 2's is 10 12ths. Times 6's is 6 12ths with a 2. Adding together, 15 plus 10 is 25 over 12. That goes in there 2 times, and I'm left with 1 12th left over. 2 plus 5 is 7, plus 2 is 9. 9 and 1 12th. And last is number 28. Whole number times denominator is 12 plus 3 is 15 over 4. Whole number times denominator is 9 plus 1 is 10. 10 over 3. And times 8 is 8 over 1. 3 goes into 15 5 times. 4 goes into 8 2 times.